We are going to start the session soon. Everybody who is outside are requested to come back into the hall and please take your seats. We are about to start the session, next session. It's very important session. All of you are requested to come and take their seats. Thank you.
Come back after the delicious lunch. May I request to invite our chairpersons, Dr. Mahendra Kumar Jaiswal sir, the senior consultant physician with special interest in diabetic field. He has published various journals in various papers in national and international journals. And Dr. Akash Kumar Singh sir, senior consultant medicine diabetology with non-interventional cardiology and president IDCM. Please sir. I request our honorable chairperson to call the first speaker, please.
To begin with the session, I will call the young cardiologist from Borda, interventional cardiologist from Borda, Dr. Kamal Chawla, to give a talk on AI tools to predict heart failure. He is head of interventional cardiology, Ward Wizard Group of Hospitals in Borda, and has numerous procedures in cardiology to his credit, and also numerous publications in cardiology to his credit. So, Dr. Kamaldeep Chawla, please.
Yeah. Thank you, sir, for the wonderful introduction. How do I load my slide? Yeah. So, we had an enchanting oration talking from our Vedas, and so now I come on to something that is future. That is artificial intelligence tools to predict heart failure. So as a human, I know that I can learn from experience, but the machine can also learn from the data that we feed into it. And that is what I want to concentrate on this. And also taking a cue from the previous talk, there is a crosstalk between Vadodara and Varanasi. You took away our most famous member of parliament. So, we do know that heart failure remains a significant challenge in cardiology, with growing emphasis on leveraging artificial intelligence to enhance prediction, prognosis, diagnosis, and management. The tools are very diverse, and as clinicians, we should know what tool to pick up, because plethora of equipments are going to barge the industry, and then we'll have to select. But the most important data that is going to come is from implantable devices, wearable sensors, and diagnostic tests. So over the ages, we have all been implanting these devices, and I think that data is going to be of major help. I'm only going to talk about the focus that has been allotted to me, that is heart failure. So artificial intelligence and heart failure, it is AI-aided diagnosis, monitoring and management, estimation of disease severity, phenomapping of patients, especially with HFpEF, prediction of risk of incidence of heart failure, and predicting the response to therapies. First of all, when this topic was allotted to me by our esteemed Dr. Mishra, I thought why this topic has been given to me. And then on searching the literature, I thought that there is a huge amount of gap that exists between what we have and what we want, and that is in terms of something called tailored medicine. There is still a lack of truly personalized approach in heart failure, taking into account individual factors like genetics, lifestyle, and disease factors. It is essential to define the most appropriate therapeutic strategies depending on patients' comorbidities. Early detection, stage A, we want to pick up even before that. Remote monitoring is still a dream for a country like ours. Predictive modeling, to support decision making and improve patient management, it is advisable to improve prediction of its progression. So suppose we integrate the data from a database that we have, and when the patient walks into our clinic, the nurse is already going to put that patient into red category, ke sir, iska to pro-BNP बढ़ गया है. So this is what we want the systems to integrate in our day-to-day practice. And as I just said, integration of data. So how AI works, it's a very big topic, only 15 minutes. So AI works by predictive analysis, imaging analysis, and wearable technology. clinical decision support systems, remote monitoring and telemedicine, and risk stratification of treatment options. So as you can see in this cartoon, the existing approach is expert-driven knowledge acquisition, which goes on to knowledge transformation, and then clinical decisions are made on it. We get guidelines integrated to our decision making. And the proposed approach is that whatever we have, on that we put in hybrid knowledge, where the machine learns from itself, it auto-regulates, updates the guidelines which have been released even yesterday into the system, and we get our patient treatment options. So the tools and models are, one is machine learning, various machine learning algorithms such as logistic regressions, decision trees, random forest, and support vector machines. These are all IT related terms which have come into the forte, and we doctors will have to learn these. Deep learning models, the deep learning techniques like artificial neural networks, convolutional neural networks, and recurrent neural networks have been applied to analyze various medical data and predict the heart failure problems. Predictive analysis software, clinical decision support systems, mobile health applications, and genetic algorithms are available and going to come into practice, which we'll be using very soon. So artificial intelligence is a program that can sense, reason, act, and adapt. Machine learning uses algorithms whose performance improve as they are exposed to more data over time. And the third layer when it comes is the deep learning, subset of machine learning, which multi-layered neural networks learn from vast amounts of data. So if I have to finish my talk at this level, this one slide is enough to bring artificial intelligence into medical forte. So in terms of artificial intelligence, we have data from various tools. Machine will start learning from these tools and prepare its own triage, its own patient severity models. And depending on that, when we put in the third layer of deep learning, yesterday's released British guidelines will come into the screen, and we'll know that yes, now our category patient is not B but A, or vice versa. Just an example to make you know. So this is a cartoon of machine learning and deep learning. Machine learning applications of machine learning and device therapy for heart failure. So a digitally health integration occurs wherein increased patient engagement occurs. That goes on to risk stratification and phenographing, bringing upon that improved prognostic modeling and enhanced perioperative workflow is made out of it. And in deep learning, the machine already uses this data what the machine has, and depending on the latest features which bring into its forte, it analyzes from internet, it analyzes from guidelines that are already available for its algorithm, and prepares a data sheet that which we can use. So I also thought that I also learn and make you guys also know all these IT related linguistics. So what are neural networks? The cartoon is a neural network. It makes a mistake and it learns from it. So all of us have to become like a neural network. We get data, we may misanalyze it, oh, it's okay. You get a corrective command and you go on to make it a correct version. So ANNs, or artificial neural networks, are general purpose and widely used. This is an example of neural network. So with various inputs, machine has its own hidden algorithms and we get an output out of it. So the applications are handwriting recognition, image compression, traveling salesman problem, and stock exchange prediction as in general. But when we want to bring this into the forte of heart failure, the application of ANNs is basically to give us a diagnosis out of a CT image or a diagnosis out of a very confusing echo image. So this is what we can get in artificial intelligence. Convoluted neural networks, these are some things which excel in image related tasks. The convolutional layers apply filters to input images, extracting features like edges, textures, and patterns. It pulls down these layers into something which is very, very objective and removes the subjectivity part out of it. So to make us understand that we have apples and lemons in this diagram, and there are three apples in this picture, and the machine is made to learn that how to prepare a basket out of this input which has been given to it. So there is a first CT image, then you bring in an MRI image, and then the machine automatically predicts the diagnosis that what it has prepared for us. And the most important and advanced stage of learning, that is deep learning, goes into the use of RNNs, or that is recurrent neural networks, which are effective for sequential data analysis. So these are designed to handle sequential data where the order of element matters, such as time series, data, text, speech. Unlike feed-forwarded networks, RNNs have connections that forms direct cycles, allowing them to retain the memory of the past inputs. And each neuron in this network, not only from the current step, but also from the previous state, potentially generates an earlier time step. So this is something which will be used in early prediction of heart failure. So this is an example of the recurrent neural networks, wherein we have an input, we have a hidden layer, and then the machine has its own output layer before giving the final output. So the clinical applications of artificial intelligence in CHF management are telemedicine and mobile health, neural language processing, Internet of Things, AI-powered platforms, wearable devices, monitoring devices, and data analysis of echo, ECG, MRI, etc. So in terms of telemedicine and mobile health, one of the possible applications is home technologies. We have a tailored personalized treatment planning, correct dosing, and identify patients at risk for adverse events and readmissions. I think this will take the burden of major healthcare problems when we get AI into full-featured platforms. Various examples exist like Veta Health, Wellby remote monitoring platforms. So these will offer tremendous potential for monitoring health through phone calls, text messages, data recording, highly portable peripheral devices, activity monitoring, which may find utility for novel modes of healthcare delivery. So an example of basic thing like impedance technology available to patient at home, puts in a finger, we get that the fluid level is rising. The call comes to the nurse asks questions to the patient, and the treatment is delivered at home. So before patient lands into class 3, class 4 for an admission, in NYHA class 1, maybe an early class 2, we treat the patient at home. Monitoring devices and AI-powered platforms. So this we all know. We have getting various apps also for this. So various latest, one of the models that is available in US is a Heart Logic from Boston Scientific in terms of this. Internet of Things is the concept that is based that various electronic sensors embedded in objects that are regularly part of our environment by means of a common software platform. So I just want to share something. It's a very busy slide. In my new hospital where I have taken over as Director Medical Affairs, I'll be joining in 15 days. We have imported a bed from Dubai. So there are 8 beds. The beds have 7 sensors embedded in them. So it's a totally wireless monitoring for the patient. And suppose 2 patients belong to Dr. Mishra, 4 patients belong to Singh, and 5 patients belong to me. My patient's data will come on my mobile, his patient's data will go to his mobile, and his patient's data will go to his mobile. So this is something of what the need was and what we integrate using the latest technology that is available. Natural language processing. So computers have the ability to understand text and spoken words in same way as humans. What is Alexa? It's a form of artificial intelligence that has come into our lives. So NLP-based tools might become special tools, particularly for home-based monitoring of CHF patients for early recognition of clinical worsening. Dr. Patni, in his busy practice of 100 patients a day, he may say 2 patients, Alexa, please monitor these 2 patients, and he'll get the data of those 2 patients. Sorry. So application of AI to echo, ECG, and cardiac MRI. So I'll not go into details of this, but it is basically getting a clearest image by application of AI and getting diagnosis itself, suggestions, and then we just sort out the matter amongst ourselves. A very good application on the way, some of us may have it, some of us may get it, is smart clinics. So smart clinics is something which is a medical institution that create new value and insights on patient safety, quality of care, and cost effectiveness using information and communication technology. Examples of AI tools specifically designed to predict heart failure. So there is many of them. HeartFlow, CardioMEMS, IBM Watson, CardioEye, eICU collaborative system, HeartLogic, HeartMap, HeartFlow, FFR-CT analysis in our cath labs, and MyoVista, which is a ECG learning program. Beyond such a glorified lecture that I am giving, challenges and considerations do exist. So data privacy, interoperability, and regulatory compliances are of critical considerations. Clinicians' education and training is of utmost importance, and continuous validation and refinement of AI algorithms. So there will always have to be a tech team behind all of us to manage the systems. So to summarize, AI tools encompass a range of technologies designed to predict, monitor, and manage heart failure patients. Advanced algorithms, including machine learning, what my daughter calls ML, and deep learning, what she calls as DL, they are ahead of us, to analyze various data sources as medical imaging, devices, and sensors, to improve patient outcomes by facilitating early intervention, personalized treatment strategies, and better outcomes of heart failure. These tools also hold immense potential to revolutionize the heart failure care by providing cardiologists with advanced predictive analytics, image analysis, variable monitoring devices, clinical decision supports, and treatment optimizations. However, a great collaboration between researchers and clinicians is required. The future perspectives are multiple applications, shifting from research models to specific health issues, truly personalized interventions, and helpful to support the discovery and deliverability of new devices. I know all of us are going to laugh, but artificial intelligence was asked to make a picture of Mother Teresa fighting against poverty. And very, very bad, apartheid in this picture, poverty means black, even for AI. So thank you, and I want to end that 2045, not very far away from many of us, is an avatar program which is going on. So basically by 2040, we can transmit the entire data from a diseased brain to its hologram, and that person will be living at least in the AI world with us. Thank you.